solving quadratic equations using the method of substitution. So what we are going to learn in this is a technique or a trick that we can use to solve some quadratic equations that don't appear to be like quadratic when we look at the first time. They look something weird, and then we can actually transform them into a quadratic equation by using this technique of method of substitution. So let us try to take some examples, and then we will learn how to use this method of substitution. And let us take an example like, so I'll take an example x4 plus 2x square plus 1 equal to 0. So when we see at the first sight, this equation looks to be a equation in the fourth degree of x, and we may be thinking about how to solve this kind of a equation. So here what we typically do is we will actually try to substitute. That means we are going to replace y for x square. So I will let y be x square. So this equation then becomes, so this equation then will become, for x4 it will be y square, and for x square it will become y plus 1 equal to 0. So what we have done is we transformed the variable x square as y and then substituted it for and then made it. So now this looks like a quadratic equation. So this is the technique. So that means we are basically using the method of substitution to transform into a quadratic equation. Now we can solve this one, because this is very simple, because this is like y plus 1 whole square. We know that this can be squared, so this is a perfect square. So now what we get is y equal to minus 1. Now what we are looking for is the values for x and not y. So how do we get to x is we will substitute. So we will actually substitute like this. So x square will be equal to minus 1, because here we see that y is x square, therefore x square is minus 1. So we know that by simplifying this we will get x is equal to plus or minus square root of minus 1. And remember, square root of minus 1 is an imaginary quantity, so we can even write this as plus minus I. So we got two roots, x is equal to I and minus I. So the question is, where are the other two roots? Because when you have a degree equation 4, we should get 4 roots. So the answer is, this is actually a double root. That means y is equal to minus 1 is a double root. That means it occurs twice the same value, and therefore these roots are nothing but I minus I. So our 4 roots therefore are I minus I, I minus I. So these are the 4 roots. Now what we can see from here is that we have used the method of substitution to transform a very high order degree equation and then made it very simply a quadratic equation. So here we have used the method of substitution. Let us take another example so that you will appreciate how this method of substitution is so powerful, because it can solve a variety of problems that don't appear to be quadratic at the first place. So I'll take an equation 6 to the power of 2n plus 1 plus 6 square is equal to 6 to the power of n plus 6 to the power of n plus 3. So we want to find the value of n. So in order to do this equation, one should again think about the fact that what is troubling us is the 6 to the power n, and we are not sure how we can actually get rid of 6 to the power n. So what we will do is we will again use substitution. So we will let x be equal to 6 to the power of n. So let us see what happens. So when I write this equation again using our properties of exponents, I can write 6 to the power of 2n plus 1 as 6 to the power of 2n times 6, because you can add the exponents when two numbers multiply with the same base. And then we will write 6 square as 36. We will leave 6 to the power n as it is because it is already in the simplest form, and then we will write this as 6 to the power of n times 6 to the power of 3. So what we have done is we have tried to reduce everything possible into 6 to the power n. Reason is we are substituting x for that. So how do we do that? So remember, 6 to the power of 2n is same as writing 6 to the power of n square, because you multiply the exponents when you do this one, and this will become 6 plus 36 equal to 6 to the power of n plus 6 to the power of n times 216, because 6 cube is 216. So let's put the coefficients on the left side the normal way, and now we will substitute for x into this one. So what happens is I will get 6x square plus 36 equal to x plus 216 times x. Now let us solve this one by moving all the terms. So we will get 6x square minus 216x plus 36 equal to 0. So we have tried to put it like a ax square plus bx plus c format. So now what we see here is that, okay, we actually made a mistake here. X plus 216 is 217. So we should write 217 here. So anyways, still it is a quadratic equation in x, and we know how to solve this kind of equations because we have learned previously that we can use factorization method. So remember, 6 times 36 is 216. So you can see that 6 and 36, when we multiply, it becomes 216. So that means for 217 what we get is, we leave like this and we factorize 217 as minus 216x and minus x, because if I add them it becomes 217 plus 36, and remember when I multiply these two we get 216, so we are good. So now we will try to factorize this as x minus 36 minus 1 into x minus 36 equal to 0. So the two factors are 6x minus 1 and x minus 36 equal to 0. So which leads to x is either 1 by 6 or x is 36. We get two answers here. Now our job is to find n, not x. So what we do is we substitute like this. So 1 by 6 is equal to 6 to the power n. So which means we can write 6 to the power of n is 6 to the power of minus 1, because when we write 1 by 6 we can make it a negative exponent and write it as minus 1. So this leads to n is equal to minus 1 is one of the answers. The next one is 36. So we will write 36 is equal to 6 to the power of n. Now convert 36 as base of 6, it becomes 6n is 6 square. So what does it give? We give n is equal to 2. So we actually got two answers, n equal to minus 1 and n is equal to 2. So we have been able to solve a complicated equation. Let's recap what we have done here, just for the sake of understanding the method of substitution. Is we took 6 to the power n because we suspected that 6 to the power n is something that can be replaced. So we took x as 6 to the power n, and then we, using our law of exponents, we broke this equation into this form, as you can see here, and then we were able to substitute wherever 6 to the power n occurs, we were able to substitute x for that one. So when we did that, it became a very apparent quadratic equation that we are all familiar with, and then the remaining is all about factorizing the quadratic equation, which we should be able to do. The last step, however, is that we always need to get back to our original variable. X was just an intermediary variable for substitution, but what we need to get is the answer for n, and therefore we put that back and then we get these answers. So this is the method of substitution. So you have seen that there are two examples we have taken where we have tried to demonstrate how method of substitution can be so powerful and able to transform complicated equations into simple quadratic equations, and we can solve. So this is good to know, because learning these techniques will help improve your ability to think and also to be able to solve. So let us try to now take one more example which is a little bit complicated to look when it looks. So what we want to do is we want to actually find out the value of this expression. That means we get, let us take 90 square root of 90 plus another square root of 90 plus another square root of 90, and this goes on and on, this never ends. That means we say that can we find the value of this expression square root of 90 plus square root of 90 plus like that, and it goes till infinity. That means it never ends. So how do we find this one? So you will be surprised to know that the method of substitution helps so much that we can use that. So what we do for this kind of equation is we first let y be equal to this expression. So we will write as 90 plus 90 again and plus 90. So like this. So we have just used y, let y be equal to this one. So remember that when we look at this expression, look at this inside expression. See here what happens. If I were to separate this out, this would be, the blue box would still look like a 90 plus square root of 90 and so on. Even if we remove 190, it doesn't change because it is infinity. Adding or removing one numbers doesn't really matter. So we still get the same y here. So I could have written this by using our method of substitution. We would write this as y equal to square root of 90 plus y, because the blue box is still y, because we just showed that when we bring this blue box out, it still appears like a y. So let me write with blue so that you will be able to understand that the blue box has been substituted for y again. So this is another way of using the method of substitution. So how do we solve this equation is we square both sides. So when we square both sides, we get y square equal to 90 plus y. And now we can use our standard quadratic equation format where y square minus y minus 90 equal to 0, and we can see that there are factors 10 and 9. So let us put that here, y square minus 10y plus 9y minus 90 equal to 0, and when we factorize this one, we get y minus 10 plus 9 into y minus 10 equal to 0. So what do we get here is, we get here y plus 9 and y minus 10 are the factors. So what we get is y equal to either minus 9 or y equal to 10. So we know that this cannot be the answer, because the sum of 90 plus something else, it has to be greater than 0. It's a positive number. So sometimes we do get extraneous solutions for our quadratic equations, and we have to be aware that these have to be ignored. Therefore the answer is 10. So this answer y is 10. So that means the expression's value, this is actually as simple as 10. The answer is 10 for this. And again we have used the method of substitution to solve this expression. So we have demonstrated 3 different techniques where the method of substitution was very powerful in converting weird looking equations into quadratic equations and then get the answer.